Hi friends, welcome back on our YouTube channel. Today in electronics, we are going to discuss about optoelectronic diodes. Now, what is optoelectronic diodes? If optics is involved in electronics, then such type of device is known as optoelectronic device. So here we will discuss about optoelectronic diodes. So first of all, light emitting diode, that is LED. Now LED. First of all, principle of LED. In simple PN junction diode, the energy bands are indirect. Simple PN junction diode are germanium and silicon type diode. So if diodes are made up of these type of semiconductor, then their energy bands are indirect. When these diodes are forward biased, then the recombination of electron holes across the junction starts. Now, we connect simple PN junction diode in forward biased, then what happens? The recombination of electron hole across the junction starts. When electron jumps from higher energy level to lower energy level, then it emits energy in the form of photon. In simple PN junction diode, this energy lies in invisible region, so we cannot see it. So when electron jumps from higher energy level to lower energy level, then the energy emitted by electron in these diodes will be in the form of heat, and hence we cannot see it. But in some special type of semiconductor, the energy bands are direct. These semiconductors are gallium arsenide. When these semiconductor diodes are forward biased, then what will happen? In the process of recombination of electron hole pairs, the electron jumps from higher energy level to lower energy level, and the energy emitted in this case will lie in visible region, so we can see it. The energy emitted during this process lie in the visible region and is clearly seen due to transparent material of crystal. Since these diode, which diode? The diode made up of gallium arsenide semiconductor. So these diodes emit light energy on forward biased, hence they are known as light emitting diode. So this special type of diode emit the light or emit the energy when electron jumps from higher energy level to lower energy level, and this energy lie in visible region. So these diodes are known as light emitting diode. Now, construction of LED. In LED, generally we use gallium arsenide or indium phosphide. So this is our arrangement of LED. Here we have electrons and here holes. So when electron jumps from higher energy level to lower energy level, then in this process electron hole recombination starts, and this is the light or energy, because here electron jumps from higher energy level to lower energy level, so it emits energy, and this energy is in the form of visible light. So this light can be easily seen, and here we have transparent surface, so the light which emitting during this process can be easily seen due to this transparent surface, and this is the symbol of LED arrow in outward direction showing that light is emitted in such type of diode. A means anode or K means cathode. In these diode, N-type semiconducting layer grow on a P-type substrate by diffusion. Now, this is our arrangement. After it, a thin layer of P-type material is grow up on N-type layer. At the external sides of these layers, a thin metallic contacts are attached which are connected to cathode, and cathode is indicated here by K and anode is indicated by A. So at the external sides of these layers, a thin metallic contacts are attached which are connected to cathode and anode respectively. So this is our cathode and this is our anode. The whole arrangement is placed in a transparent plastic cover or envelope. The color of plastic cover depends on the light emitted by diode. So which type of light is emitting by the diode? The color of plastic cover depends on this. This was our circuit symbol and this is also circuit symbol, and this actually shows the transparent plastic envelope. LED is always used in low forward bias. The wavelength emitted by the diode depends on the percentage of arsenic in gallium arsenide phosphide diode. So, what is the amount of arsenic in gallium arsenide phosphide diode? The light emitted by diode depends on such percentage of error of arsenic. The common formula is gallium arsenic 1 minus x px. So we just put here the value of x and we get the formula for such diode or such LED. Gallium arsenide gives infrared light and gallium phosphide gives light of blue color. If the energy band of above diode is 1.8 electron volt, then we get light of red color. And if this diode is doped with nitrogen, then we get light of all the colors ranging from yellow to green in visible region. So the light emitted by diode depends on the energy band of the diode. The wavelength of emitted light is given by lambda equal to hc upon Eg. Here h is Planck's constant, c velocity of light, and this Eg is our energy gap or band gap. Since h and c are constant, so if we put the value of these two constant, then lambda equal to 1.26 upon Eg in terms of micrometer. If we join 7 segment of LED, then we can get any number from 0 to 9. So here we are showing the 7 segment LED. This LED is represented by A, this is B, this one is C, D, E, F and G. This is the connection of 7 LED, 1, 2, 3, 4, 5, 6 and 7. So if we connect 7 LED, then we can create 7 segment, and here we are showing a digit 4. So to get 4, F, G, B and C LED are lighted up, and if we want to get number 2, then 2 is our this figure. So A, B, G, E and D. So if A, B, G, E and D LEDs lighted up, then we get number 2. So in this way we can get any number from 0 to 9 by using 7 segment LED. Now, uses of LED. LED are used in calculators. It is used in watches, used in platform signals, used as a pilot lamp in electronic device for showing on-off position, and also used in optical communication system. So these are the uses of LED. So here we end our session. You can get the notes of this lecture and the link of that notes are given in our description box. So you can directly click on that link and get the notes of this particular lecture. So goodbye.